Picture this, a spacecraft, a marvel of human engineering, embarking on an odyssey that spans nearly 2 decades. This isn't just any journey. It's a voyage covering billions of kilometers through the vast emptiness of space. The sheer scale of this mission is mind-boggling. To put it in perspective, if this spacecraft were traveling to our nearest stellar neighbor, Alpha Centauri, it would have only covered about 0.04% of the distance in the same time frame. But where is this intrepid explorer headed? Its destination is a realm that has captivated humans since we first turned our eyes to the night sky. A world renowned for its stunning rings and enigmatic moons. A planet that seems to float in space, adorned with a halo that defies imagination. Yes, we're talking about Saturn, the jewel of our solar system. You might think this sounds like the opening of a blockbuster sci-fi movie, with CGI effects and dramatic music. But here's the kicker. This isn't fiction. This is the real-life saga of the Cassini-Huygens mission, a testament to human curiosity and technological prowess. This epic journey did more than just explore a distant world. It revolutionized our understanding of Saturn, its moons, and the very nature of our solar system. The Cassini-Huygens mission showed us wonders beyond our wildest dreams, transforming abstract astronomical concepts into tangible realities. Now, let me blow your mind even further. What if I told you that thanks to this mission, we discovered a world with rivers, lakes, and seas? You might say, well, we already know about Mars and its ancient waterways. But here's the twist. I'm not talking about water. On this alien world, these liquid bodies are made of methane. Imagine standing on the shore of a methane sea, watching hydrocarbon waves lapping at an icy coastline. This isn't science fiction. It's Titan, Saturn's largest moon, as revealed by the Cassini-Huygens mission. But wait, there's more. What if I told you we found a moon that's constantly shooting ice geysers into space? Picture a world where cryovolcanoes erupt with plumes of water ice and organic compounds, possibly fueled by a subsurface ocean. This is Enceladus, another of Saturn's moons, and potentially one of the most promising places to search for extraterrestrial life in our solar system. The Cassini-Huygens mission didn't just explore a new world, it redefined our understanding of what's possible in the cosmos. It challenged our preconceptions about where life might exist and what forms it might take. It expanded our horizons and showed us that the universe is stranger and more wonderful than we ever imagined. Is your mind spinning like Saturn's rings after hearing about these incredible discoveries? If so, don't keep this cosmic wonder to yourself. Smash that like button and subscribe to the Exploring the Universe channel. By doing so, you're not just supporting us. You're joining a community of space enthusiasts and cosmic explorers. Together, we'll continue to unravel the mysteries of the universe, one video at a time. So, are you ready to embark on your own journey through the cosmos? The subscribe button is your launchpad. Hit it and let's explore the universe together. The Cassini-Huygens mission stands as a testament to what humanity can achieve when we come together in the pursuit of knowledge. This wasn't just another space mission. It was a groundbreaking endeavor that pushed the boundaries of international scientific collaboration. At its core, the mission was conceived as an unprecedented partnership between 3 major space agencies. NASA from the United States, ESA representing 22 European nations, and ASI. This alliance brought together the best minds, resources, and technologies from across the globe, pooling their expertise to tackle one of the most ambitious space exploration projects ever undertaken. NASA took the lead on the Cassini orbiter, leveraging its experience with deep space missions. The ESA, on the other hand, was responsible for the Huygens probe, designed to land on Saturn's largest moon, Titan. The ASI contributed significantly by providing Cassini's high-gain communication antenna and various scientific instruments. Planning a mission of this magnitude was no small feat. The team faced numerous challenges. Designing a spacecraft capable of surviving the harsh conditions of deep space for over a decade required cutting-edge engineering solutions. The mission's extended duration meant that scientists had to anticipate technological advancements and plan for equipment that would still be relevant years into the future. Aligning the goals, budgets, and timelines of multiple space agencies required diplomatic finesse and unprecedented levels of cooperation. Balancing the diverse scientific interests of international teams while maintaining a cohesive mission plan was a constant challenge. Securing and maintaining funding for a long-term mission across different countries and changing political landscapes was a significant hurdle. Despite these challenges, the international team persevered, driven by a shared vision of unraveling the mysteries of Saturn and its moons. After years of meticulous planning and preparation, the Cassini-Huygens spacecraft finally lifted off on October 15, 1997, from Cape Canaveral Air Force Station in Florida. This launch marked the beginning of an epic 7-year journey to reach its distant destination. The path to Saturn was far from a straight line. To conserve fuel and gain the necessary velocity to reach the outer solar system, the mission planners devised an intricate trajectory that would use the gravity of other planets to slingshot the spacecraft towards its target. This complex route included a flyby of Jupiter, December 2000. Each of these planetary encounters served a dual purpose. They provided the gravitational assist needed to propel Cassini-Huygens towards Saturn, and they also offered valuable opportunities for the spacecraft to test its instruments and capture data about these planets. The Jupiter flyby was particularly significant. Not only did it provide the final boost needed to reach Saturn, but it also allowed for a dress rehearsal of sorts. The team used this opportunity to test Cassini's instruments on a gas giant, preparing for the main event at Saturn. Maintaining a spacecraft in the depths of space for 7 years was no small challenge. The mission team had to contend with. Cassini used radioisotope thermoelectric generators for power, which needed careful monitoring and management. As the spacecraft traveled further from Earth, maintaining clear communication became increasingly difficult, requiring precise antenna pointing and powerful transmitters. Keeping Cassini on its precise trajectory required constant calculations and occasional course corrections. Ensuring all scientific instruments remained accurately calibrated over the long journey was crucial for the mission's success. Balancing the spacecraft's temperature as it traveled through varying radiation environments was a constant concern. Throughout this long journey, the international team worked tirelessly, monitoring every aspect of the spacecraft's health and performance. Their dedication ensured that when Cassini-Huygens finally arrived at Saturn on July 1, 2004, it was primed and ready to begin its groundbreaking exploration of the Saturnian system. This incredible journey not only demonstrated humanity's technological prowess but also our unwavering spirit of exploration and discovery. After its 7-year journey across the solar system, Cassini-Huygens finally reached its destination on July 1, 2004. This moment, known as Saturn orbit insertion, was one of the most critical and nail-biting phases of the entire mission. The spacecraft had to execute a precise maneuver to slow down and allow Saturn's gravity to capture it into orbit. This required firing Cassini's main engine for a nerve-wracking 96 minutes. During this time, the spacecraft was out of contact with Earth as its main antenna had to be positioned away from our planet to act as a shield against dust particles from Saturn's rings. When Cassini re-established contact, confirming its successful insertion into Saturn's orbit, mission control erupted in cheers. It was a triumphant moment that marked the beginning of a new era in our exploration of the ringed planet. With Cassini safely in orbit, the spacecraft began its scientific observations in earnest. The first images and data it sent back were nothing short of revolutionary. High-resolution pictures revealed Saturn's rings in unprecedented detail, showing intricate structures, gaps, and even shepherd moons that help shape the rings. Cassini's instruments also provided new insights into Saturn's atmosphere, detecting lightning storms and a hexagonal storm pattern at the planet's north pole. These early observations immediately began to reshape our understanding of Saturn and its dynamic systems. As Cassini settled into its exploration of Saturn, attention turned to its passenger, the Huygens probe. On December 25, 2004, Cassini released Huygens, sending it on a 22-day journey towards Titan, Saturn's largest moon. This separation was a critical moment, as Huygens would need to operate independently to achieve its mission of landing on Titan's surface. On January 14, 2005, Huygens began its historic descent through Titan's thick atmosphere. This was a moment of immense scientific anticipation, as Titan was the only moon in our solar system known to have a substantial atmosphere, and its surface had remained a mystery hidden beneath dense haze. The descent lasted about 2.5 hours, during which Huygens collected a wealth of data about Titan's atmosphere. It measured wind speeds, atmospheric composition, and even recorded the sounds of its passage through the alien air. As Huygens pierced through Titan's haze, it captured the first-ever images of the surface of an outer solar system moon. These images, transmitted back to Earth via the Cassini orbiter, revealed a landscape both alien and strangely familiar. Scientists and the public alike were astounded to see what appeared to be shorelines, drainage channels, and flat plains. When Huygens landed, it became the most distant human-made object to touch down on another world. The probe continued to transmit data for about 90 minutes after landing, providing crucial information about Titan's surface conditions. The data from Huygens, combined with ongoing observations from Cassini, led to some of the mission's most surprising discoveries. Scientists confirmed the presence of liquid methane on Titan's surface, existing in the form of rivers, lakes, and seas. This made Titan the only world beyond Earth known to have stable bodies of surface liquid. These methane features behave much like water does on Earth, with a methane cycle analogous to our water cycle. Titan experiences methane rain, which erodes the icy bedrock, forming river channels and collecting in large basins. The discovery of this Earth-like, yet utterly alien landscape on Titan has profound implications for our understanding of planetary processes and the potential for life in the universe. It expanded our conception of habitable environments and opened up new avenues for the search for extraterrestrial life. Is your mind spinning like Saturn's rings after learning about these incredible discoveries? If so, don't keep this cosmic wonder to yourself. Hit that like button to help us continue bringing the marvels of the cosmos to you. And if you're hungry for more space exploration, subscribe to Exploring the Universe for your regular dose of cosmic adventures. Together, let's keep unraveling the mysteries of our amazing universe. With the Huygens probe's mission complete, Cassini continued its solitary journey, embarking on an extensive exploration of the Saturnian system that would last for over a decade. This phase of the mission yielded some of the most groundbreaking discoveries in planetary science. Exploring Saturn's magnificent rings in unprecedented detail. Cassini's high-resolution cameras and spectrometers allowed scientists to study Saturn's iconic rings with a level of detail never before possible. The spacecraft revealed that the rings are not just simple bands of ice and rock, but complex, dynamic systems. Cassini identified intricate patterns within the rings, including waves, spokes, and gaps, some caused by the gravitational influence of Saturn's moons. The probe's instruments determined that the rings are primarily composed of water ice, with traces of rocky material and organic compounds. Data from Cassini suggested that the rings might be younger than previously thought, possibly forming within the last 100 million years. The spacecraft detected a phenomenon dubbed ring rain, where material from the rings is pulled into Saturn's atmosphere by the planet's magnetic field. While Titan had been a primary target, Cassini's exploration of Saturn's other moons led to equally exciting discoveries, particularly on Enceladus. In 2005, Cassini detected plumes of water vapor and ice particles erupting from Enceladus's south polar region, revealing the moon to be geologically active. Further investigation suggested the presence of a global subsurface ocean beneath Enceladus's icy crust, heated by tidal forces from Saturn. Analysis of the plume material showed the presence of organic compounds, adding to the moon's astrobiological interest. Cassini provided unprecedented insights into Saturn's complex atmospheric and magnetic environments. The spacecraft studied the bizarre hexagonal storm at Saturn's north pole in detail, observing its structure and dynamics. Over its long mission, Cassini observed seasonal changes in Saturn's atmosphere, including shifts in temperature and storm activity. The probe mapped Saturn's magnetic field, revealing its interaction with the solar wind and its influence on the planet's moons and rings. Cassini's long-term observations revealed that Saturn's rings are far from static. The spacecraft discovered propeller features in the rings, caused by small moonlets disturbing ring particles. Cassini observed changes in ring structure over time, suggesting ongoing processes of ring formation and destruction. The probe detailed how Saturn's moons, particularly the shepherd moons, shape and maintain the ring system through gravitational interactions. Enceladus's subsurface ocean, a possible habitat for microbial life? The discovery of Enceladus's subsurface ocean and active plumes has profound implications for the search for life beyond Earth. Analysis of plume composition suggests the presence of hydrothermal vents on the ocean floor, similar to those that support life in Earth's deep oceans. The detected organic compounds and molecular hydrogen in the plumes indicate potential energy sources for microbial life. The combination of liquid water, organic compounds, and energy sources makes Enceladus one of the most promising places in our solar system to search for extraterrestrial life. Titan as a laboratory for studying prebiotic chemistry. Cassini's long-term observations of Titan, combined with data from Huygens, have positioned this moon as a unique environment for studying the chemistry that may lead to life. Titan's atmosphere is rich in organic compounds, potentially similar to Earth's early atmosphere. The moon's methane-based hydrological cycle provides a unique system for studying how complex molecules might form and interact in a non-water-based environment. While Titan's surface is too cold for Earth-like life, some scientists speculate about the possibility of methane-based life forms or subsurface water-based life. These revelations from the Cassini-Huygens mission have not only transformed our understanding of the Saturn system, but have also broadened our perspective on the potential for life in the universe. The mission's legacy continues to influence planetary science and astrobiology, inspiring future missions and driving new areas of research. As Cassini's mission neared its end after 13 years of groundbreaking exploration, NASA scientists faced a crucial decision. With fuel running low, they had to determine the spacecraft's ultimate fate. The decision they made would lead to one of the most spectacular and poignant endings in the history of space exploration. The decision to end the mission spectacularly. The primary concern was to prevent Cassini from potentially contaminating Enceladus or Titan, moons that might harbor conditions suitable for life. Engineers and scientists realized that a controlled descent into Saturn's atmosphere could provide unprecedented data about the planet's interior. The team decided to choreograph a Grand Finale, a series of daring orbits followed by a final plunge into Saturn. In April 2017, Cassini began a series of 22 weekly orbits that threaded the gap between Saturn and its innermost ring. These final orbits, collectively known as the Grand Finale, were incredibly risky but scientifically invaluable. Cassini sampled particles from Saturn's rings directly, providing new insights into their composition and origin. The spacecraft made detailed measurements of Saturn's upper atmosphere, helping to refine models of the planet's interior structure. Precise tracking of Cassini's motion during these orbits allowed scientists to map Saturn's gravitational field with unprecedented accuracy. The probe made the closest ever measurements of Saturn's magnetic field, revealing surprising complexities. Cassini's final day was filled with anticipation and bittersweet emotions for the mission team and space enthusiasts worldwide. In its final hours, Cassini transmitted its last images, including poignant views of Titan and Enceladus, the moons that had yielded so many discoveries. At 7:55 a.m. Eastern Daylight Time, Cassini sent its final signal to Earth. The spacecraft's last message was received 83 minutes later due to the vast distance. Plunging into Saturn's atmosphere at about 70,000 miles per hour, Cassini continued to transmit data for as long as possible before disintegrating like a meteor. The event was watched live by millions around the world, marking the end of an era in planetary exploration. The Cassini-Huygens mission dramatically reshaped our knowledge of Saturn, its moons, and the outer solar system. It revealed the complexity and ever-changing nature of Saturn's rings, challenging previous assumptions about planetary ring systems. The mission discovered potentially habitable environments on these moons, expanding our understanding of where life might exist in the universe. Observations of Saturn's system provided new insights into the processes of planetary and moon formation. Long-term observations allowed scientists to study seasonal variations on Saturn and its moons, enhancing our understanding of atmospheric dynamics. Cassini-Huygens set new standards for planetary exploration and inspired numerous future endeavors. Exploration. The mission's success has fueled interest in further exploration of the outer planets and their moons. Cassini's long-duration mission in a challenging environment has influenced the design of future long-range spacecraft. The successful partnership between NASA, ESA, and ASI has become a model for large-scale international space missions. The mission's stunning images and discoveries captivated the public, inspiring a new generation of scientists and engineers. Cassini-Huygens has significantly influenced astrobiology and the search for extraterrestrial life. The discovery of potentially habitable environments on Enceladus and Titan has broadened our conception of where life might exist. The mission's findings have spurred increased interest in exploring ocean worlds throughout the solar system. Observations of Titan's complex organic chemistry have provided new avenues for studying the origins of life. The mission's discoveries have directly influenced the planning of future missions focused on the search for life, such as potential returns to Enceladus or Titan. The Cassini-Huygens mission stands as one of the most successful and influential space exploration endeavors in history. Its legacy continues to shape our understanding of the solar system and our place within it, inspiring us to push the boundaries of exploration and scientific discovery. The wealth of data it provided will continue to yield new insights for decades to come, ensuring that even though the spacecraft itself has been consumed by Saturn, its scientific impact will live on indefinitely. The Cassini-Huygens mission stands as a monumental achievement in the annals of space exploration, embodying humanity's enduring quest to understand our cosmic neighborhood. This mission represents. It demonstrated our ability to design, launch, and operate a complex spacecraft over vast distances and extended time frames, pushing the boundaries of our engineering capabilities. The mission's comprehensive study of the Saturnian system showcased our commitment to deep, sustained scientific inquiry, going beyond initial discoveries to build a nuanced understanding of complex planetary systems. The foresight required to conceive and execute a multi-decade mission highlights our capacity for long-term scientific planning and commitment. The mission's ability to adjust to new discoveries and pursue unexpected avenues of research exemplifies the flexibility crucial for successful space exploration. Through its stunning images and groundbreaking discoveries, Cassini-Huygens captured the public imagination, reminding us of the awe-inspiring nature of space exploration. The Cassini-Huygens mission serves as a prime example of the power and necessity of international cooperation in advancing scientific frontiers. The collaboration between NASA, ESA, and ASI allowed for a more ambitious mission than any single agency could have achieved alone, combining financial resources, scientific expertise, and technological capabilities. International cooperation brought diverse viewpoints and approaches to problem-solving, enhancing the mission's scientific output and technological innovations. The mission fostered positive international relations, demonstrating how science can transcend political boundaries and promote global cooperation. The international nature of the mission facilitated the broad dissemination of scientific findings across different countries and research institutions. The success of Cassini-Huygens has paved the way for future international collaborations in space exploration, establishing protocols and relationships that benefit subsequent missions. The legacy of Cassini-Huygens extends far beyond its operational lifespan, continuing to shape our understanding of the universe. The discoveries of potentially habitable environments on Enceladus and Titan have dramatically expanded our conception of where life might exist, influencing exoplanet research and the search for extraterrestrial life. Observations of Saturn's rings and moons have provided new insights into the processes of planetary system formation and evolution, refining our models of how solar systems develop. The long-term study of Saturn's atmosphere has enhanced our understanding of gas giant planets, informing both our knowledge of our solar system and the study of exoplanets. The mission's findings, particularly regarding the organic chemistry on Titan and the subsurface ocean of Enceladus, continue to drive new research in astrobiology and the origins of life. The questions raised and discoveries made by Cassini-Huygens are directly influencing the objectives and designs of future missions, both to the Saturn system and to other outer solar system destinations. The vast amount of data collected by the mission continues to be analyzed, with new findings still emerging years after the mission's conclusion, ensuring its ongoing impact on planetary science. The Cassini-Huygens mission has not only transformed our understanding of Saturn and its moons, but has also reshaped our perspective on the solar system and our place within it. It stands as a testament to human curiosity, ingenuity, and the power of international scientific cooperation, continuing to inspire and inform as we look to the next frontiers of space exploration. If this Saturnian odyssey has ignited your passion for space exploration, don't let the journey end here. Subscribe to the Exploring the Universe channel to continue unraveling the wonders of our solar system and beyond. From the mysteries of distant exoplanets to the latest breakthroughs in astrophysics, we're your ticket to the cosmos. Hit that subscribe button now, and join our community of space enthusiasts. Together, we'll dive into the secrets the universe still holds, exploring new horizons and expanding our understanding of the cosmic tapestry we're part of. Don't miss out on our upcoming episodes featuring cutting-edge space missions, mind-bending cosmological concepts, and the latest astronomical discoveries. Your adventure through the universe continues with just one click. Remember, every new discovery starts with curiosity. So, are you ready to keep exploring? Subscribe now, and let's embark on this cosmic journey together.